afternoon, and we first give before starting presentation, we have three supporters for me. First is Dr. Archana Jain from Professor and Head Veterinary College from Jabalpur, Madhya Pradesh. Our second co-chairman is Dr. Gautam from Rajasthan, Jaipur, PGI, from Rajwasu, Rajasthan Veterinary University, and Dr. Manish Kumar from a PhD person, a young scientist, and future of SAPI. Now I request your Dr. Shah, RG Shah, you are present 12. Oocyte recovery rate by transvaginal ultrasound guided ovum pickup in Kankaraj. Thank you, sir. Let us, your presentation time is only 3 minutes and 2 minutes for question and discussion. Be quick, Dr. Sir.
Thank you, sir. Respected chairman, co-chairman, and podium, and the delegates. Good afternoon to everyone. I am presenting oocyte recovery rate by transvaginal ultrasound Kankaraj cattle. There has been tremendous increase in the ARTs since last 30 years, and worldwide there are 80% of the OPU IVF is being performed, and this is technology in the India are very primary stage. Transvaginal oocyte pickup is a vital procedure for retrieving the oocyte from a live and previously genetically superior animal, and the indigenous breeds, they are very hardy and they can accustomed to the climate change, and they can perform well in the adverse climatic condition also. So Kankaraj is a native breed of the cattle in which this study has been carried out. The oocyte recovery rate was counted as per the number of oocyte recovered, expressed as percentage of the number of follicles aspirated for individual cows. So there are 4 factors. They may have impact on the oocyte recovery rate. First is estrous cycle stage, puncture frequency and operator experience, aspiration vacuum pressure, hormonal pretreatment of the donor animals. These 4 factors have influence on the oocyte recovery rate. So together with the in vitro fertilization of the oocyte, OPU has been taken as the most flexible, unique and repeatable technique to produce embryos from the given donor animal. So work was carried out at the state-of-art facilities at the NDDB, where OPU, IVP laboratory is present. So 6 healthy cycling donor cows, Kankaraj donor cows, multiparous cows were selected. They were examined for gynecological conditions, and the high genetic superior animal from the field genetic improvement program of NDDB, they were selected, and their feeding and managemental conditions were ideal for all animals. Coming to the ovum pickup procedure, epidural anesthesia was given, and OPU media was kept in warm during ovum pickup by placing same in the dry water bath in the aspiration unit. The vagina and ovary was held tightly against the probe rectally. Needles guided was inserted with the needle mounted on the OPU handle. Started the aspiration pump around 45 to 55 pressure. Oocyte aspirated transvaginally, ultrasound guided ovum pickup. All visible follicles were counted and aspirated. After aspiration, collection was immediately sent to the laboratory and their oocytes were searched. So prior to and post OPU, the follicles were counted. The oocytes were aspirated by OPU technique. Total 46 OPUs were conducted during the study period. The OPU in each animal were repeated in the interval of 3 weeks. Normally 2 weeks are preferred. Here we prefer 3 weeks. Oocytes were evaluated and graded as per their qualities. So this is a procedure performed by one of my PhD students. His next presentation will be done by him in this aspect. So this is the collection of the oocyte. The ovary is being held in front of the vagina, and the needle is guided toward the ovary. And this is the OPU handle with the needle left, and OPU guided needle with USG probe, and OPU handle cover in the right.
Okay.
So this is the aspiration pump. So this is the way how the oocytes were punctured, and this is the USG image of the aspirated follicle. And and this is the US image of the eco-tip needle during the aspiration. So IVF laboratory of NDDB, then inverted microscope donor pancreas cows. So among the 46 OPU session, the 29.74% follicles were aspirated, and the oocyte recovery rate was 20%, 20.52, and the recovery rate was 69%. So among the 46 OPU, 69% oocyte recovery rate was observed, and the oocytes were graded, and the grade 4 oocytes were highest among all grades of the oocytes, and total oocytes recovered were 20.52%, 20.52 total. So this is oocyte before maturation and in vitro matured oocytes. So concluding this topic, this is the first time study carried out in the pancreas animal, and this is very much required in the indigenous animal, as we have to improve the genetic potential of the native predator, and this is one of the most economical ART that can improve the genetic potential at a lower cost, as Indian farmers or cattle breeders are price sensitive. So among them, grade 4 oocytes were highest number, and this can be further studied for the production of the embryos. With this, I thank everyone for the questions here.
Thank you, sir. Topic is open for question and discussion for 2 minutes.
The next presentation is related to this, and it will be presented by my student, Dr. Falgun Kapadia. So you may ask to him or me, no worry, but you can have more idea after his presentation.
The question answer will be done after that presentation.
Yeah,
Let us call
Falgun.
8, abstract number 8.
Thank you.
Your good name, please.
Dr. Falgun Kapadia, FM Kapadia.
M.N. Kapadia.
FM
Good. FM Kapadia. 3 minutes for presentation.
Please start presentation number 8.
Okay. Comparison of 2 media in current cattle with respect to oocyte recovery, cleavage and blastocyte.
Yes, sir.
Start presentation.
You start, please give introduction.
Very good morning, one and all. I am Dr. Falgun Kapadia from Amdin University, Gujarat. Today I am here to present my research work on to compare the oocyte media for the production of in vitro embryo production in pancreas cattle with respect to oocyte recovery, blastocyst and cleavage. Please start presentation 8.
You can say if presentation is not available there.
Okay, so I will start. Up to the right start.
Whatever you want to, you give conclusion.
As we know that the vocal for local and the
Go for method and conclusion. That's all.
Nowadays, the various reproductive technologies are available. Among these, in vitro embryo production, it is the very useful tools if we use as a selection and the breeding of with the selecting animal which are genetically superior animal. Due to the global warming, there is a various fluctuation in the environment or in indoor conditions, so that ultimately leads to the decrease in the milk production. But our pancreas cattle, that is the indigenous breeds of our Gujarat, having the unique characteristics like the heat tolerance and pest resistance.
We know this. Go to the product.
Okay. Obviously, various kind of media available for the in vitro embryo production. Majority of are there the serum and the serum-free media. Okay, but this serum has the biophysic effect. Serum also accelerates the development and growth of the morula and the blastocyst, and also it provides the energy substance, amino acid, vitamins, growth factors, and heavy metal cellulose. But that detrimental effect, that is, it produces the large offspring syndrome in the sheep and cow, and it will also increase the number and size of lipid droplets around the embryo, which retards the growth of the embryo. Our work is carried out with in the company university collaborative work with the NDDB, where the specialized laboratory available for the embryo production. If we talk about the in vitro embryo production, the main first step that is the ovum pickup, where we are recovered the good quality oocytes. Then good quality oocytes are kept for the maturation in the maturation media in specialized incubator. Then whatsoever the mature media, they are kept for the in vitro fertilization. This mature media is fertilized with the semen from the concrete pool, which are genetically superior. Then after fertilization, we check the cleavage rate. Then after we kept this zygote in vitro culture media in the specialized benchtop incubator. And then after 6 to 7 days, we check the zygote and graded. If the good quality recipients are available, then we go for the transfer. Otherwise, we kept for the preservation, either from the vitrification or the slow method. This is the little photographs where we the different steps are available for the embryo production. The main point that is that we have to select the elite donors animal, and we also have to select the good quality semen for the. So total OPUs are divided in two groups. In group A, there is 25 OPUs, they are eroded, and the group B, that is 21 OPUs are eroded, and the sequential process of both are same in the group A and the group B. That is the in vitro maturation, fertilization, culture, and finally we observe the cleavage and the blastocyst rate. Group A is treated with the subjected with the Vitrogen IVF media, and group B it is subjected with the IVF bioscience media. So this is the photographs.
Okay.
This is laboratory.
Okay.
This is a concrete donor cow. Total oocyte recovery rate in our research work, that is 70%, which is little bit higher as compared to group B, but that is not significant. This is the cleavage rate, also found little bit higher in group B, that is the bioscience media, which was also non-significant. Then during this research work, we divide the blastocyst in the 4 different stages: early blastocyst, expanded blastocyst, and hedge blastocyst. Among these 4 different stages of blastocyst, we recovered the expanded blastocyst are higher as compared to different 4 stages of blastocyst. This is the blastocyst rate of 2 groups. In the group A, that is reported 24%. In the group B, that is the bioscience media, reported 23%. But it is also non-significant. This is the core result of our research work. Here we can see that the blastocyst rate and the oocyte recovery rate, which was reported higher in Vitrogen media group as compared to the bioscience media group, and in the bioscience media group, we recover higher cleavage rate as compared to the Vitrogen media group. This is the oocyte before and after. This is the photograph taken during the fertilization. Around we can see that this is the spermatozoa which are attached with the rings surrounding the oocytes. This is the photograph taken after the 72 hours, where we can see the cleavage rate is start. This is the morula stage. This is the early blastocyst, where the blastocyst cavity began to develop, and it occupies majority of 60 to 70% of total perimeter space. This is the blastocyst stage, in which we can easily differentiate the tropoplastic cell and the inner cell mass. This is the expanded blastocyst, in which the embryos are increasing the size, and the width of the zona pellucida start to decrease. So this is, in this stage we can see that the embryos are begun to shading the zona pellucida, and in this stage we can see that the embryos totally shade the zona pellucida. And this might be a spherical, or sometimes it also seems like collapsing structure. So this is the both structure, expanded as well as the hedged blastocyst. So from our research work, we can conclude that the oocyte recovery rate, they are little bit variation in the group A and group B. There is not significant. Cleavage rate of blastocysts are also found good in both the group. That is also not significant different. And expanded blastocysts are found higher as compared to different 4 stages of the blastocysts. And finally, we can say that the higher oocyte recovery rate in the subsequent development of embryo by this Vitrogen bioscience media, which was resulted in the higher cleavage in the blastocyst rate, which is suggestive for the beneficial effect of Vitrogen bioscience media. And finally, we can say that both this Vitrogen as well as the bioscience media warranting its usage for the in vitro embryo products in concrete scatter. This is the first work in concrete scatter we have done.
Okay. Topic is open for question and discussion.
Thank you, sir.
For 2 minutes.
जो आपने स्पर्मेटोजोआ यूज किया ना, फ्रेश है या फ्रोजन?
नहीं, फ्रोजन है सर, फ्रोजन है. We sir want to try the sex semen, but there is no found the good result. That's why we found only. No sir, there is no any supervision, because this is OPU method without any supervision.
Open pickup, no hormone is required.
What is the half-life of both media?
What, sir?
What is the half-life of both media?
Sir, it is a company made, sir. And half-life there is a within opening, within 12 hours after opening this bottle, sir.
For both?
Both, sir.
Self-life, self-life.
Sir, what the procedure only difference is there, the H and pH. These are added in the fertilization medium. Otherwise, the both are the similar procedures. And the main difference is that when we use the vitrogen media, we have to preserve for the overnight incubator, and there is no need to preserve. Only 4 to 6 hours are required for the maturation to equilibration.
Okay. We have 3 important questions. What is the recovery rate, average recovery rate of good quality oocyte per attempt? ओपन पिकअप का I'm talking about. पर अटेम्प्ट में आपको कितना पर एवरेज मिलता है?
पर सर इसमें रिकवरी में फ्रॉम 0 to 160 oocytes.
No, average है.
Average 20
Per attempt. Per attempt.
Sir, there is also variation, sir.
Correct, 20 average.
Only average 20, sir.
Average 20. And what is the fertilization rate after that?
After that, fertilization rates are around.
See the table.
70 है ना?
70, sir.
Okay, thank you for your project.
That is the oocyte level, there is 70%. Average is 74%.
Okay.
I have one question, Dr. Vishesham.
Sir.
Very good presentation.
Yes, thank you, sir.
But next story, after transfer, what was the consumption rate?
So we tried but not taking the consideration for the transfer, but sir, only, this is the first time we are transferring.
The study was allotted, PhD study was allotted.
Result transfer has not been done.
Transfer not has been done,
But
sir.
in other projects,
In other project, we have
200 pregnancies with this project. More than 200.
What I am saying is when you are transferring embryos from Anchorage here,
yes, sir.
because this will not be the end of the story.
No, sure, sir. There is not.
Definitely,
Yes,
sir.
sir. We have.
Transferring Anchorage
In
embryo.
the sir, we are trying. Yes, sir.
Fresh, what is the consumption rate? Frozen embryos, what is the consumption?
Yes, sir.
Not yet attempted.
Not yet attempted, sir. But
Out of discussion.
You have thrown these embryos.
no, sir. We have kept for preservation, sir. Frozen, sir.
Hatch blastocyst.
No, sir.
Certain embryos.
Certain embryos are kept for preservation, sir.
Our study was limited to this only.
But it must be part of whole study.
That is the NDDB. NDDB they have utilized it,
That you are not
but they have not submitted the idea.
You have not talked to them. But my suggestion will
This is sure, sir. This is not the end, sir. Yes, sir. This is not the end.
This is beginning.
Further process required.
This is beginning. This is beginning.
Yes, sir.
Transfer is last. Preservation and transfer is done. As you know, Dr. Misra is a pioneer of buffalo transfer in India.
Yes, sir. I already.
You know this.
Yes, sir. Yes, sir. Yes, sir.
From very beginning we know it.
Yes, sir.
Thank you. For next presentation.
Thank you. Thank you.
Presentation number 14. Development of technology to increase semen production and consumption rate. Pradeep Kumar from Befali Research.
Please select presentation 14.
Pradeep Kumar, please come.
Good afternoon to all. I am going to present the development of technology to increase the semen production and consumption rate. So, as we know that still the artificial insemination is we are adopting, but the AI coverage is still 30%. And consumption rate is 35%. And our aim is to increase the productivity that is present about the 2000 kg per animal per year. So we have to increase up to 8,000. Therefore, we have to increase the AI coverage from 30% to at least 60-70%, and we have to increase the consumption rate. Still, it is 30%. It is very poor overall. So, and also we have the acute shortage of the elite wool. So we have the option to increase. We have to adopt some technology to increase the cement production as well as the consumption rate with the existing wool with the intervention of some technology. So how can we increase the AI coverage rate, which is the 30%? For this, we have to increase the cement production from the existing wools. And we have to harvest maximum sperm from the existing wools. And also we have to reduce the cement dose reduction. As presently it is 20 million, so we have to reduce it to increase the demand to cover the most of the animals. What it is 30%. And again, second question is our consumption rate is still 35%. So this is why we are using these different additives and supplements in every publications. Still our consumption rate is the 35%. The reason is still the mortality is the 50 or more than 50, but there is a changes which are not visible. When we see the sperm motility, that is called capacitation like changes, cryocapacitations or premature capacitations. So our aim to decrease this capacitation like changes during the cryopreservation process. So we have aim to reduce this capacitation like changes by using some inhibitors, some new extenders. Also, after this, the maintaining the keeping quality of the frozen cement at the end user, and we know that our inseminator are laymen mostly. They are not how to use the cement, frozen cement. They many times the cement liquid nitrogen level goes down, and we do not know, and our whole cement doses are deteriorated, and we do not know the actual the sperm is live or not in our doses, and they are continue to inseminate and conception rate is low. So this is the one of the two reasons of the low conception rate. So if we have focus in our research to improve this one. So from 1931 we are using the AV, and still we are using the same AV, and as you know that when the temperature of the AV will be low, what will be happen? It will happen, there will be poor thrust, fail to donate semen if donate low sperm concentration. If there is a high temperature, some sperm may be killed and burning of penis, and that bull will have bad experiences, that bull will not donate for the long time. So there should be change in the AV.
Okay, carry on.
Sir, so we have modified the AV in which we have attached one sensor that displays continuously the temperature. So because the inseminators, those are involved in the semen collection, they do not know the exact temperature which is required, because as from the semen processing lab, semen AV lab, they given to the AV collector, they do not know the temperature. In the winter, the temperature goes down very fast, and in warm season they down very slow. So some bull donate at high temperature, some bull donate at the low temperature, but the semen collector exactly do not know the temperature. So we design the one AV, existing AV, we have put some sensor and display so that those involved in the semen collection can know the AV temperature, and if temperature is goes down, they can change the AV so that we can harvest the maximum sperm. This AV is so designed so nicely that can be fully autoclaved as per our the MSP, and it is battery operated. There is no need of extra current or required. Sensor is in contact with the water so that it gives the real time temperature, so that semen, those person are involved in the semen.
Nicely depicted. Go on next.
So we have this commercialized this one and sell this cement to the Chemtron Analytical, who is dealing the mini tube India.
Next.
So using this AB, I am not going to detail about that, but by using this AB, we have seen at 60,000 cement dosage, it increased 10 to 15% cement dosage from the booths, from the same booths. This is the advantage. We can increase the cement production by using this AB.
Okay.
So second target is our increase the cement production by reducing the sperm numbers. So we worked on this and we reduced the cement dosage 20 million to 12 millions, and we found there is no effect. And also we evaluated the consumption rate. We found using this LDL extenders, and this consumption rate is also higher.
Okay.
So in this way we also increase the cement production from the existing booths. Then second thing is we have to think beyond the egg yolk extender. 1939 we are still using these egg yolk extenders. So first time we measured the progesterone concentration in the egg yolk extender. It is 284 nanogram per ml. In oviduct it is only 1.5 nanogram. So you can think how concentration of progesterone is, how many times it is higher. Progesterone is inducing the capacitation. So when we using this may be one of the reason the capacitation like changes occur in by using this extenders. Also we measure the calcium. It is very high in the semen extender, and those working in the IVF they know that in vitro capacitor calcium is only 2 millimole, while in our extender it is 584 millions. So next strategy, our next strategy was that why not we put the anti-progesterone in the semen extender, and we after adding the semen extender RU4X, it is anti-progesterone, it significantly reduced the capacitation like changes. Also we use the H89, which is inhibitor of the protein kinase, which is cascade reaction. In cascade reaction of the capacitation is the protein kinase, which is mainly involved to induce the capacitation. And we depicted this in big picture how we can reduce the this capacitation like changes by this inhibitor. And this is the peculiarity of this inhibitor is it is reversible. So when we do the AI with this supplement, after the AI, this is reverse and normally capacitate in the uterus. So in this way we can reduce the capacitation like changes in the yolk-based extender. So next aim was to why we use this this inhibitor. Why not we use the unwanted substances found in this egg yolk-based extender? So we remove all the unwanted substances from the egg yolk, and we found that the progesterone concentration reduced to this concentration to this one. And also calcium is reduced this ones. And SDL, this is the also inducer of the capacitation. The high density lipoprotein is 3. It is no excess progesterone in this extender, no calcium, no enriched with the LDL, and we found that there is a significant reduction of the capacitance. So there we have 3 options to reduce the capacitation like changes by using inhibitor or remove all the unwanted substance by this technique.
Okay.
So lastly, I said that after capacitation, this sperm motility at the end user is reduced due to the many times goes down. They do not top up at required times, and also many times canister they use. So they do not know, but there is in field there is no instrument that can measure the sperm motility in semen dosage are there or not, or dead due to the mishandling of the semen dosage. So there is no instrument, so we have fabricated this instrument, and this is the single objectives and closed and temperature operated, and we can see and what you can this video you can
Video is going on. Video is going on.
So, in the field, inseminators can check their semen quality at the field level also before while cutting the end point. They can excuse the 1 drop of semen and check at the time of the insemination and ensure that we have that those has inseminated was live sperm in there or not. So in this way we can also increase the conception rate. So in this way we can increase the production and we increase the consumption.
Thank you for questions. Good presentation. Operational research from a fellow research institute.
It's a very informative presentation. Sir, आपने egg yolk का कुछ दिखाया था? Egg yolk को क्या किया? Did you reduce the concentration?
We remove the unwanted substance from the egg yolk. Only we keep the LDL, low density lipoproteins.
How you keep?
This is the protein precipitation. We add the ammonium sulfates and we put the dialysis and all other substances, HDL, progesterone, calcium, almost it is removed in this process. So it is free.
LDL, just you kept LDL only.
LDL and some antioxidant.
Thanks for next presentation.
Thank you,
Abstract number 1 from Junagadh. Effect of white blood cells on functional competence of gir bull spermatozoa.
Presentation.
Number 1.
So please, number 1, RN1.
What is your name, please?
Dr. Ramesh Padodra. Very good afternoon.
First name, no?
RNE1.
RNE1. Ramesh.
Yeah. So very good afternoon, respected chairman, co-chairman and reporter and the dignitaries and the scientists in the hall. So today I'm going to present some effects of white blood cells on the functional competence on the gir bull spermatozoa. So we know the leukocytospermia is the pathological condition is to be seen in case of not in human but in animals also. So where some counts of the WBC are increased in the semen, then it leads to the fertility. Lots of things has been demonstrated in the human criteria, but it is not there in case of the animals. We are not judging the WBC count in the semen in case of the at the time of the collection of the semens. So the first time we have just tried to investigate the number of the leukocytes in the semen from the gir bull, and also we have seen the different studies. Okay, what count of the WBCs are to be effect on the either the physiological, morphological parameters of the spermatozoa during the by putting in the in vitro cultures, and also we have seen the some effects of the white blood cells on the oxidative parameters of bull spermatozoa during the in vitro culture. So the studies has been done in the Department of Biology, and we have collected 18 neat semen collections from the gir bull, and here we took the 6 bull, and all the criteria for the collection of it is ideals what we have it is to be needed, and this was our actual experimental design where we ejaculate the gir bull semens, where we collect the semen, neat semens, and we count for the leukocytes by the light microscopy, and from the dilute semen, the spermatozoa at the 1 million cells per ml, and we have spermatozoa with the 50, 500 and 5000 WBCs, and then we studied the physio-morphological parameter and oxidative parameters. And for the semen culture applications, almost the WBCs are to be separated from the gir bull blood only, and the different number of the leukocytes, 50, 500 and 5000 numbers are to be separated, and it is to be cultured percentage of talc media, and this was the swarm concentration, and the WBC cells are to be incubated or in vitro culture with the samples. So these are the parameters and methods we have used during our whole experiments and analysis as per the whatever is today. The first investigations, we find the different kind of the stain with the GIMSA and the DAPI. So yes, the leukocytes counts has been demonstrated by this way, and the counts we have observed that we make a one mean total count of the WBC in a neat Siemens, in a healthy Siemens, where 0.5 plus or minus 0.1 million cells per ml. So this is the range what we have find in the total number of the what neat Siemens samples we have collected. The second objective study the morphological parameters. So this is the viability of the sperm dead and live, what we have usually seen with the eosin eosin staining, and the viability and motility of the sperms, where we have incubated this semen culture at up to the 4 hours. So this is the control T1, T2 and T3, where the different number of the WBCs are to be in vitro with the medias. So when we found that at the 4 hours, the viabilities had to be reduced, and same, the motility also will be reduced in the 4 hour at the 5,000 WBCs. Then the mitochondrial membrane potentiality also we have observed with the bright rims, JC1 stains, and at the mid piece, the high indicate the different potentiality we observe in these slides. Similar, the slides we have here stained with the JC1 staining, and we find some pieces with the low membrane potentiality and the high membrane potentialities. And this is the result we have find it at the 0 hours, where we find, and between the 0 and 4 hours, we find that it's too much reductions of the membrane potentiality is to be there with the more than 500 cells WBC are to be there. It is in the semen. Then come to the plasma membrane integrity. Also we have observed is being with the hypoosmotic swelling, what we call as a hostess. Again, here we also observed at the 4 hours incubation or culture, we'll find at the treatment 2 and 3, where the number of cells were more than 500, when we find the host person's reactive cells is observed. Again, the acrosomal integrity also to be stained with the GIMSA stain, and we find the results similarly in case of the more than 500 cells, we find that at the 4 hours the acrosomal integrity is reduced. Then next objective was to perform the different oxidative parameters, where we find the lipid oxidations, glutathione transfer activity, total antioxidant capacity. In all that, find that at the 4 hour, at the 5,000 cells, where we find the significant differences we observe. What is the rates marking are to be there. Lastly, the summary and conclusion of the experiment was that the first time we have just released the basic data of the leukocytes present in the beer bull, and that was the 0.56 millions per ml leukocytes are to be there in that, and in both the objective where the 500 or more leukocytes per million grid cement spermatozoa affect the physiomorphological, and of course they cause this oxidative damage to the semen. The conclusion is said that more than 5,000 million sperms affect the physiomorphological parameters and cause it oxidative stress, resulting reduction in the functional competence of the good semen parameters. Thank you.
Thank you, Dr. Ramesh. Topic is open for discussion and questions. Not any questions? The next is thank you very much, Dr. Ramesh. Now I will call abstract number 2, Dr. R. Ranjan from Mathura. Anybody present?
RNE2.
RNE2. Anybody? Next.
I think so.
RN3, Manish Kumar, Ravi Ranjan, and Alok Bhardwaj. Central Institute of Boat, Bagdom.
I think, sir, they are not present.
Nobody is there, no? Okay. Now, RNE4, PSP Gupta, he was there, present. Dr. Gupta. Okay. Anybody from National Institute of Nutrition and Physiology, Bangalore? Gupta, I have seen Gupta. RNA-05. Studies on hair cortisol. Gupta Akanksha. From St. Buffalo?
RNA-5.
Buffalo Research Institute. Okay. Akanksha, we have only 3 minutes. Consider yourself accordingly.
Good afternoon to you all. I am Dr. Akanksha Gupta. I am going to give my oral presentation on topic Studies on Hair Cortisol, Testosterone and its association with semen quality in buffalo bulls. Hair cortisol and testosterone gives us the long-term retrospective study of the animal's life. They both have steroid hormones and they are incorporated into the hair shaft with the passive diffusion from the blood. Objective 1, estimation of hair cortisol and testosterone, concentration in male buffalo bulls and testosterone in male buffalo calves. And second objective is to correlation analysis of hair testosterone and cortisol with the semen quality in buffalo breeding bulls. For the first objective, we selected 15 bulls and 10 male calves, and hair samples were collected from the scapular region, and they were collected at 2-month interval for the whole year for 12 months. And about 6 samples were collected in 2-month duration, and they were stored in the aluminium foil, and further analysis was done. These are the steps to extract hair cortisol and testosterone. Firstly, after collection of the hair, the washing of hair was done with isopropanol, and then they were dried in incubator and they were crushed with the liquid nitrogen in a fine powder form. And we used about 60 milligram of hair and for further processing, and we added about 1.5 ml methanol, which was kept on a shaker along with the hair, crushed powdered hair, for about 12 hours. And further supernatant was collected after centrifugation, and this supernatant contains methanol, and this methanol has the tendency to evaporate, and we evaporated it, and this was further diluted with the ELISA buffer, and then ELISA was done. This is the first study which includes the hair testosterone and cortisol estimation and its association with the reproduction. As I've already told, why these hormones are to be estimated in hair, because they provide us long-term retrospective assessment of the hormone. For the objective 2, we identified the bulls on the ejaculate discard rate. It is the semen which is not stored in the form of straws, that is discarded, because it cannot pass the first initial test, that is individual motility test. And there were 2 groups were created. First is the bulls having consistent semen quality throughout the year. The sampling duration was 12 months. And second group was inconsistent semen quality bulls. And for the semen, assisted semen analysis parameter, CASA parameters, and flow cytometry parameters, sperm mitochondrial membrane potential, sperm mitochondrial superoxide, and acrosome intensity. These are the results. Here are the 2 groups. You can see the results in blue are the consistent semen quality bulls, and the results in the red are the inconsistent semen quality bulls. And see, discard rate was also recorded according to the collection of hair. In every 2 months, the sample was collected for about 12 months. And here, the results are showing the ejaculate discard rate of 2 to 2 months duration. And for the estimation of hair cortisol concentration in the bull, we have found that in the month of August, there was significantly higher hair cortisol. But in the month of May and April, there was less concentration of hair cortisol. It may be because that in the month of August, see in Hisar, the study was conducted in Hisar, the temperature and humidity is high. So we have found that the hair cortisol can be associated with the stress of the animal. But in our study, we did not find any correlation correlation of hair cortisol with the ejaculate discard rate of the bulls. This is the estimation of hair testosterone in bulls. Similarly, as we have estimated cortisol, we have also estimated hair testosterone. We have found a negative correlation of hair testosterone with the ejaculate discard rate. R value was minus 0.557 and P value is 0.002. Here it is a graph showing the testosterone concentration in picogram per 100 mg of hair among different months. See, we can see in the month of October and April we have higher testosterone concentration. It might be due to that bulls are more comfortable in these months, and therefore as it can be compared with discard rate, the testosterone is high and bulls are having lesser ejaculate discard rate. So I also did my study on calves. So this is the increase in the testosterone concentration. I have collected sample of starting from 6 months. Age of calf was 6 months. So it significantly increased with the age of the calves. You can see the levels are increasing. I have collected up to the 16-month age calves, and similarly in the 2 months interval for 12 months. See, these are the parameters. For consistent semen quality bulls, we have discard rate about 15%, and for inconsistent semen quality bulls, we have discard rate of about 56%. See, in my study, I found that there was significantly high correlation with the discard rate. So, the 46 picogram per 100 mg hair was found in consistent semen quality bulls. No significant change was found in the hair cortisol concentration, and the flow cytometric parameters of the semen of consistent quality bulls were significantly higher than inconsistent semen quality bulls. That is, high mitochondrial membrane potential was significantly high, and ecosome integrity was also significantly high in case of consistent semen quality bulls. But we can see mitochondrial superoxide, which is lower in consistent semen quality bulls than the inconsistent semen quality bulls. These are the CASA parameters, and there was no significant correlation found between in the CASA parameters of consistent semen quality bulls and inconsistent semen quality bulls. Summary of my study is the consistent semen quality bulls have higher testosterone concentration than the inconsistent semen quality bulls, and hair testosterone increased significantly with the age, and high mitochondrial membrane potential, ecosome integrity, that is flow cytometric parameters, were significantly higher in case of consistent semen quality bulls, whereas mitochondrial superoxide was significantly lower in consistent semen quality bulls. So conclusion, there was negative correlation found between hair testosterone concentration and ejaculate discard rate. This hair testosterone concentration can be used as a useful biomarker in assessing the future breeding bulls. Thank you.
Thank you, Akanksha. Topic is open for question and discussion.
Actually, Dr. Sir, as you have shown that during the month of August, I think at that time, that is summer season.
Yes.
So, as you have shown that during that time, testosterone concentration was lesser, I think.
Yes, it was.
So, did you correlate with the ejaculation?
Yes.
Different ejaculate and that different semen parameters like motility and other parameters?
Yes, ma'am. We did the correlation. The testosterone concentration in the month of August was comparatively lesser than you can see in the month of October. Okay, the discard rate was also high because there was this study was conducted in Hisar. It has very high temperature, about 46 degrees. So temperature and humidity was very high, and the discard rate was increased a lot at that time.
During the time of August.
Because see, this is a hair sample. You know, the steroid hormones are incorporated.
Definitely, because the testosterone has the direct relation with the...
See, this was the first study. Here we tried to, we all know that cortisol is a stress. So we tried to correlate it directly with the reproduction. So my work was on a male part. So we tried to correlate directly with the semen quality parameters, but we did not find any significant correlation. But in case of testosterone, we do find it. Even this was the first study to have a direct hair testosterone.
That means during the time of August, when you compare with August and October,
yeah,
all the parameters was significantly or not significantly differ from this.
See, the the ejaculate discard rate. It is the first parameter. When we have semen in the lab, what we do, we just check its individual motility. Just simple dilute it and then check it.
A long discussion can be done personally.
More than 70%, we keep the sample.
A small question and now can be
This is the ejaculate discard rate, which is not. Yes, we had significant help.
There's the answer.
Thank you. What is the difference between, what is the advantage of determining testosterone in the hair and not in the serum? Just one.
This is very, very good question you asked. Very good question. Actually, in serum there is.
You can use this speaker.
In case of serum, we do get both free and bound form. Okay, but in case of hair, we get only free form of the hormone available. And most important is, it is not affected by circadian rhythm or the day by day fluctuation. The hormone gets accumulated in the hair slowly. In case of cattle, there is 0.6 to 1 centimeter growth of hair in a month. So we just collected 2 centimeters of hair from a particular site.
कितनी रेंज तक का, कितने टाइम पीरियड तक का हमें ये नॉर्म स्केल करना है? जैसे लाइक we do
2 months, 60 days, minimum 60 days are required.
retrospective.
Yes, 60 days. So it is very, you can see it is very good, it gives very good estimation of cortisol. Stress can be estimated very easily. But in my study, I couldn't find any correlation with the semen quality, but in case of testosterone, the hormone gets incorporated and I directly found the correlation with the discard rate. And it is the first study in the world to directly find the correlation of it's just a hormone. We are just doing it in hair.
Akansha, good presentation.
Thank you.
We have understood it. Thank you very much. Next one is RNA 06. Again from
Please load RNA 06, Poonam Kumari Singh.
Present. Anybody from this group? No. Next. 7. Call 7.
RNA 7.
Krishna Bansal.
Bansal Krishna, please load RNA 07.
Bansal Krishna.
Good morning to all. Today I am going to present my oral presentation on the topic of sperm motility patterns of buffalo semen ejaculates and labeling substance caused by CASA, flow cytometer and level free protein weight quantification. So first, sperm motility is an essential parameter for penetration of the zona pellucida, and it is generally reflect the viability of sperm cell. So this was the technical program. We collect the semen ejaculates from buffalo bulls and divide them into 3 categories on the basis of sperm motility patterns: normal motile, slow motile, fast motile, then subjected to dilution, then finally we cryopreserve it. And we assess the capacitation status by using CT-CSA in fresh and cryopreserved samples, and by helping of flow cytometry we assess acrosome integrity, mitochondrial superoxide production and mitochondrial membrane potential. And kinematic parameters was also checked by CASA, and here in fresh semen we did proteomic analysis.
Okay. No. Come to the result and conclusion.
So these were
Yeah, result and conclusion.
Come to the result and conclusion.
So we checked the percentage of the ejaculates having So this is the video of the slow motile sperm, sir. We divide the ejaculates on the basis of sperm motility patterns. And this is the
Some problem is that you can skip also.
so this is the percentage of the normal, slow and fast motile ejaculates. So this sample size were 340 ejaculates, and out of these the 13% ejaculates were blown from slow motile category, and 14% from fast and non-directional, and remaining 73 were normal motile. And we also calculate the rejection rate in fresh samples. So we found the higher rejection rate of the semen samples from the fast and non-directional motile sperm in fresh samples. In cryopreserve also, the maximum rejection rate was also in fast and non-directional motile. That was around 22%. This is the CASA results, and we didn't found any significant difference in the total and progressive motility and curvilinear straight line velocity. Only the amplitude of lateral head displacement was higher in fast non-directional motile sperm than slow motile. This is the mitochondrial membrane potential, and we found this slow motile sperm have high mitochondrial membrane potential than fast motile in fresh and cryopreserved stage. This is the acrosome integrity. So we found in cryopreservation stage the maximum intactness of live spermatozoa were in slow motile sperm than fast and normal motile, and in fresh sample there was no significant difference. The high mitochondrial superoxide production was higher in fast non-directional motile sperm than slow motile sperm. This is the result of the capacitation CTC, and we found the maximum capacitation was in fast motile sperm than slow, and uncapacitation was maximum in the slow motile than fast. And reaction, there was no significant difference in all these three categories. We also checked the host for plasma membrane integrity, and we didn't find any significant difference. For morphology, there was highly abnormal sperm was in category fast and non-directional, then slow and normal motile. This is the again CASA result in the frozen semen, and we found the total and progressive motility is significantly higher in slow motile sperm than fast. And for VCL and VSL was maximum in the fast non-directional, and LH again was higher in fast motile sperm than slow motile sperm. This is the proteomic analysis. We found total 1645 proteins in fresh semen samples of all these three categories, and there were differentially expressed proteins. Slow versus normal was 417, and fast versus 331. So these are the cellular component of the percentage of protein we found, and these are the molecular and biological function of these proteins. This is the interaction diagram of identified proteins. So this is the Venn diagram for differentially expressed protein. In slow versus normal was 242 proteins, and fast versus normal 156. 175 proteins were common in both categories. This is the upregulated expressed protein. In fast versus normal, 83 proteins were upregulated, and slow versus normal was 104, and 50 proteins were upregulated in both categories. So these are the top 10 proteins out of 83 in fast. They were upregulated. These are the top 10 out of 104 high evidence protein exclusively found in slow motile sperm. Again, the downregulated proteins in fast versus normal 81, and slow versus normal was 146, and 113 proteins were common in hyper fast normal and slow versus normal. Again, the top 10 proteins significantly low evidence protein exclusively in the fast non-directional motile sperm compared to normal motile. This is the top 10 protein again exclusively in slow motile groups in compared to normal motile sperm. This is the some important proteins that were responsible for the different types of sperm motility patterns like actin, tubulins, ubiquitin and ubiquitin, and the kinase and phosphatase proteins and the heat shock protein were responsible for different types of sperm motility patterns. So summary and conclusion. For the first time we reported 3 patterns of sperm motility in buffalo semen, and slow sperm motility patterns of an ejaculate appeared better in CASA and flow cytometric analysis. And proteomic analysis generated an important panels of conjugate proteins that may be responsible protein for different motility patterns of buffalo spermatozoa.
Okay, thank you, Doctor. Topic is open for question.
Sir, one question. Sir, how did you differentiate this non-directional and this fast sperm?
We can see in video the fast motile is going in the very quickly, non-directionally, but slow and normal have a unidirectional.
This first one is unidirectional,
yeah.
And non-directional?
Non-directional is moving in any side.
Okay. Okay, thank you. Next, well presented, Krishna. Now I would like to call SN Abedin from Assam.
RNA 9.
Khanna Paras 9.
Please upload RNA 9 SN Abedin. Is he here?
No. Next.
RNA 10. Renu Chaudhary. Is she here? No, sir, I don't think so.
No.
RNA 11. Piali Kuri.
Anybody from this group?
RNA 12 to August.
13.
RNA 13. S Sangwan.
No.
RNA 14. 14 हो गया. Thank you. RNA 15. Shamshad Ali. RNA 15.
Anybody?
I don't think any response.
16.
RNA 16. Sriti Pandey.
Sriti Pandey. Oh, 15. ये 15 है.
15. Please upload RNA 15. Shamshad Ali.
India नहीं करना.
Good afternoon to everyone. Myself Shamshad Ali. My topic is exogenous crispin protein regulator of libido and sexual behavior in Black Bengal dog. And as I told about the crispin, it is the potent secretograph of GnRH in various animal, human and lab animal. Now is the regulation of sexual behavior in male is a very scanty study, and my research is the one of the worldwide first study regarding the sexual behavior regulation in any livestock species. That is based on the receptor neurons and rat social behavior. And one of the research regarding the sexual behavior and reaction time was done from the Indian scholar, and they had used the endogenous crispin and found that reaction time was less and sexual aggressiveness and penile erection was higher in the animal having the more crispin. For this study, we have chosen 12 mature Black Bengal and divided into treatment and control group. That was 6. And for that parameter, they divided into 2 groups: sexual behavior and that regulated by this phenomenon, testosterone concentration. Then in the sexual behavior parameter, the reaction time, sexual aggressiveness, tactile stimulation, libido score, mating ability score, and sexual behavior score were evaluated by using the scorecard. And the whole study was divided into winter and summer season. In the treatment group, we have injected 2.5 microgram crispin for once in a week for 4 consecutive weeks. And after that, the parameter libido and sexual behavior was studied weekly, and the same pattern was and in the control group equal volume of NSS was injected, and the same pattern was followed for the summer season, and the sexual behavior and sexual behavior weekly, and the testosterone level was studied fortnightly interval. This is the video revealing the study of sexual behavior, and regarding the sexual behavior video, we have studied the different events of sexual behavior and evaluated by using the scorecard given by Boric that was edited by the Anjaritar. Here is the testosterone assay estimation that was used, that was collected fortnightly and estimated at the end of the research. Results. Now coming to the results, the first parameter of sexual behavior was reaction time. Reaction time was calculated from the entry of the bug to the semen collection room, and in the treatment group it was less than the control group, and more precisely it was 30 seconds, and in the control group it was more than 35 to 40 seconds. Here we can see in the second graph treatment group and the control group. They were significantly higher in the treatment group. And the sexual aggression score. We have formulated the reaction time and 4, 6, 8, 10 parameter, and the reaction time was categorized in the 6 groups. And similarly as reaction time, here the sexual aggressiveness score was higher in the treatment group. And tactile stimulation score. During the semen collection, the variant tactile stimulation presented by the bugs as the sniffing, urine licking, and butt throwing was categorized into 10 different categories, and that was also calculated in the treatment and control group.
Thank you, Shamshad.
Sir, I want to show the last slide, the conclusion and field application of exogenous restricting.
थैंक्स तो पहले
सर ये अपने आप हो गया.
बोल दो.
Sir, the field application of exogenous restrictant, it is the first research in any livestock species. We can use it to improve the reproductive sexual activities that animals showing the lower interest to copulate due to the environmental stress or any behavioral cause. We can inject it before the semen collection or before it is continuously present in the blood. There are various human research that was showed it. And second point of this application is we can use it as nasal spray to direct use by the farmers and more conveniently. Thank you.
Thank you. Topic is open for questions and discussion. Not any? Now come to the RNA 16. Thank you, sir.
Thank you, sir.
Sriti Pandey.
Yes, sir.
Okay.
Please note RNA 16. RNA 16. Sriti Pandey.
Sriti Pandey from Diva Veterinary College, MP.
Good afternoon to all the respected one present in the dais and hall. My name is Dr. Shriti Pandey, presenting the topic adhesion molecules, a prerequisite for an intimate crosstalk between the embryo and uterus. We all are well aware about the role of buffalo in animal husbandry, with the fact that buffalo is regarded as a poor breeder, and thus the success of buffalo husbandry lies on the thorough understanding of reproductive events, especially which are occurring during the early phases of implantation. But our knowledge about this complex mechanism is limited, especially in case of buffalo, and thus the arena of early embryonic uterine crosstalk in bovine species must be explored. These are the various adhesion molecules required for the implantation, their role, and the various species in which they are already studied. We can appreciate that the data is lacking on the bovine species, and thus we hypothesize that the interaction of buffalo embryos to monolayer might lead to altered distribution of adhesion molecules in early phases of implantation. We will see material method and results together. Then next, firstly we isolated the uterine cells using 0.25% trypsin EDTA and then characterized it on the basis of phenotype and molecular expression of the cell positive marker cytokeratin and cell negative marker vimentin. Then next slide. Then we supplemented the different doses of progesterone
आपके पास है slide का?
Okay. Thank you. Then we supplemented different doses of progesterone and we found 3.14 nanogram per ml progesterone was the best dose by seeing the expression of various molecules. Then our first objective was to study the effect of progesterone primed luminal epithelial cell monolayer on blastocyst hatching and attachment rate. For the determination of hatching rate, after the IVM-IVF protocol, the doe 4 embryo or modular stage embryo were co-cultured as such as control, then with steroid-treated group, epithelial cell monolayer co-cultured group and steroid-treated epithelial cell co-cultured group. And we found, these are the photographs showing different stages of blastocyst, and we found that the hatching rate was maximum in steroid-treated epithelial co-cultured group. After, these are the pictures showing the hatching rate in different groups, control and steroid treated. This epithelial cell culture group, steroid treated epithelial cell co-culture group. Then we also see the blastocyst attachment rate, and for this hatched blastocyst were co-cultured as such on plastic, on uterine epithelial cell monolayer and on uterine treated epithelial cell layer. Attachment rate was seen after 24, 48 and 72 hours of co-culture. After 24 and 48 hours of co-culture, no attachment was seen, while at 72 hours of co-culture, almost 9% of embryo were firmly attached, while 71% of embryos were loosely attached with the epithelial cells. These are the pictures showing the attached embryo on the epithelial cell and steroid-treated epithelial cell monolayer. Then the second objective was to determine the blastocyst in the expression profile of adjacent molecules in luminal epithelial cells. Again, after the IVM-IVF protocol, we co-cultured the hatched blastocyst with epithelial cell monolayer for 72 hours and the culture was kept undisturbed. Afterward, we isolated the embryo and epithelial cell and saw the expression of mucin 1 osteopontin, integrin alpha 3, alpha 6, alpha V and integrin beta 1, beta 3 subunit on controlled luminal epithelial cell, steroid-treated epithelial cell, embryo co-cultured epithelial cells and steroid-treated epithelial cells co-cultured with embryo. Also, we saw the expression of integrin alpha 1, alpha 3, alpha 6, alpha V and beta 1, beta 3 subunit along with interferon tau on blastocyst of control group, steroid-treated embryos, luminal epithelial cell co-cultured embryo and steroid-treated epithelial cell co-cultured embryo. These are all the genes shows the expression in epithelial cell as well as embryo. We found the maximum expression of alpha 6 and alpha V on the epithelial cultured with embryo. The similar expression was shown by the beta 1 and beta 3 subunit. Also, osteopontin revealed the significant expression in steroid-treated epithelial cell co-cultured with embryo and epithelial cell alone co-cultured with the embryo group. While in contrast, mucin 1 revealed the highest expression in the epithelial cell which were co-cultured with the embryo, while steroid treatment gave the negative impact on the mucin 1 expression. Similarly, in case of embryo, the integrin alpha V revealed the similar expression as we saw in case of epithelial cells, and the similar expression was shown by beta 1, beta 3 as well as interferon tau. We also saw the protein expression in case of epithelial cell but not in embryo. In case of epithelial cells, the integrin subunit alpha V beta 3 revealed the maximum expression in steroid-treated epithelial cells which were co-cultured with the embryo, and the similar result was revealed by the osteopontin molecule, while the mucin 1 revealed the maximum expression in control group. Thus, from the present study, we can conclude that this study gives us an understanding about the early reproductive event occurring during the early phases of implantation in buffalo, and this understanding may be helpful in designing new strategies to rectify implantation failure and improve pregnancy rates in buffalo. Thank you.
Nice presentation, Sriti. Topic is open for questions and discussions.
please accept my compliment. Again, it's informative. Like in case of early embryonic death, उसके साथ जब आपका रिसर्च को कोरिलेट किया जाए, आप उनमें क्या रिकमेंड करोगे?
Actually, this is the initial study in the buffalo, which can give us answer why the early embryonic failure occur in the animals. Because there is very limited study in case of buffalo, and we don't know anything about the early events occurring during the implantation failure or early embryo-uterine interaction in buffalo. So, because of the failure of these molecules or progesterone as a steroid hormone, it is having impact on these molecules or uterine cells, and these uterine cells secrete various secretome, which will help in the expression of these additional molecules.
Like as you have shown that some steroid treated groups, they have shown better result. तो उस टाइम पे कोई हार्मोन हम एक्सटर्नली दे सकते हैं ताकि हमारा जो अर्ली एम्ब्रियोनिक डेथ वो रिड्यूस हो जाए, प्रेगनेंसी रेट इंक्रीज हो जाए?
Surely. That's what we designed this experiment to see the effect of the steroid hormone, especially progesterone. We gave the basal level of estradiol also along with the different concentration of progesterone, and we found that minimum 3.14 nanogram per ml of progesterone is essential to establish the pregnancy in buffalo. So the progesterone, if animal is having lesser amount of progesterone, we can give extra, or we can inject progesterone externally. Thank you.
Thank you very much. Next, RNE 17.
RNE 17, Sumruti Mahapatra.
West Bengal, University of... No.
RNE 17, no. RNE 18, Rajesh Kumar.
BHU.
RNE 18? Please upload RNE 18. RNE 18, Rajesh Kumar. It's further metabolism.
Good afternoon to one and all. Myself, Dr. Rajesh Kumar, scientist in the Department of BPV, Dugas, Hisar, and I am here to give my own presentation on identification of stage-specific estrous cycle molecule in buffalo urine through metabolomics approach. So we already know that buffalo is a side breeder, and there is a problem in the silent heat animal. Being in a silent heat animal, that sometime during the summer, estrus detection is a problem. And so in a repeat breeder condition also, estrus, even though detect, you will fail to go for pregnancy. The whole hard work of the farmer is wasted. So our objective was to, because earlier work, as Dr. Balana have already told, that during the pregnancy diagnosis, which was our work, a collaborative work, both the paper and patent. So there we have used water, D2O molecule as a solvent. So here we have used chloroform molecule as a solvent, okay? And our objective was to decipher and compare the urinary metabolite in different stages of estrous cycle of normal cyclic and repeat breeder buffalo. So for this, the whole group were divided into 4 groups. In the group 1, 6 normal cyclic animals were taken, 6 repeat breeder were taken in the group 2, and in group 3, heifers as a control measure, and group 4, bull as a pure control measure, so that we can compare the environment and other effect also. So urine sample were collected, and also blood were also collected. All other ultrasonography and rectal examination were also done. And in urine sample, in estrus animal, that is normal cyclic animal and repeat breeder, were collected at day estrus, 2nd day, 10th day, and then after 16 days continuously to next estrus cycle. And day before that was considered a pro-estrus animal. So urine sample after taking, we have prepared, centrifuge for 12,000 RPM, 5 minutes, then filter through the syringe, and 40 degrees centigrade it was stored. Then the urine was lyophilized. After lyophilization, 700 microliter of urine, it was used deuterated chloroform as a solvent, because that is a very excellent solvent, vortex, and then add an internal extender of TSP with the buffer, filter, and they go for NMR spectroscopy. So once the data come, data was first converted to the FID data. From FID data, then it was going for analysis to the Genomics NMR software, and all data were done to a statistical analysis through Metaboloanalyst 5 software. So the file, after the conversion, the file looks like this. So this is prostress, stress, metastress, distress file. The 0 is the actually TMP internal extender that indicate you how much change of the phase is happening here. So I will not go in detail about this thing. Once the NMR result has been done, we go for Chemox NMR suite software, where after the we will go for phase correction, baseline correction, and seam correction. These are the essential protocol in order to make sure that all the samples are in the same phase with no interference with the other things. And then after, we will go to enumerate the chemicals, that what are the chemicals available in these things. So through this process, we identify nearly 195 molecules in different samples. The highest one was the 195 in the HEPAR case, while in earlier paper, as Dr. Barada discussed already, through DTO we were able to identify only 42 molecules. Even though from 42 we are lucky enough that our molecule was got so that we can able to make the pregnancy diagnosis kit. So here we have identified 195 molecules through chloroform. And this is the different molecule identified, 191 in estrus, 182 metastress, diestress, proestrus, HEPAR and bull, and similarly in the repeat breeder. So highest was the 195 molecule identified in the HEPARs. This is the whole, after the metabolite analysis, we will go for correlation analysis for different things, and these are parameters we have done for analysis. Out of those 195 molecules, 148 compounds have shown no significant difference with respect to any group and any condition. Okay? Whereas 22 molecules in the proestrus, 1 molecule metastress, 4 molecule diestress, and 1 molecule compound exclusively present or absent in case of diestress was found. So I am not revealing the detail. Already 195 molecule I have revealed because of the IPR issue, because you understand easily that this is the phase-wise typical molecule present, that means typical diagnostic kit is there. Then for what called repeat breeder, we were not able to identify the molecule which was typically present in the repeat breeder case. However, two molecules were significantly vary in the diestress. Here you can see how much variations is there, 585 and 0. That means, and that molecule can be used for further for field-based diagnostic techniques development, so that farmer himself will be knowing that there is no profit for going for AI in these case of animals, better for treatment. And these molecules are actually related with the cycle where directly they are, we have gone for pathway analysis also, and these molecules were actually directly related with the anti-inflammatory cycle, which is essential for pregnancy, what called adaptation. And so this molecule can later on also have therapeutics application also. So in conclusion, we can say that NMR is a robust method for metabolic analysis. We have found 28 molecules exclusively present or absent in 4 different stages of cyclicity, which can be used for diagnostic marker and pen-side diagnostic kit development, as we have already done in case of pregnancy diagnosis. Thank you very much.
Thank you, Rajesh. Topic is open for question and discussion.
What is the accuracy of the test?
NMR. NMR is very accurate as SPLC.
Next, RNE 19.
RNE 19, Masdatul Nisa.
SKUT.
Next, SKUAST-Kashmir. RNE 19, Masdatul Nisa, Aslub Ahmed Malik. RNE 20, Arushi Kamar.
Inshallah.
RNE 20, anybody? RNE 21, Anamika Pandey.
Early pregnancy diagnosis in SIP using fecal progesterone metabolites.
Please load RNE 21.
IVRI. Gajendra was there, but anyway, no.
Good afternoon, respected chairperson, co-chairperson and delegates. Myself Anamika Pandey, and I am here to present my topic early pregnancy diagnosis in sheep using fecal progesterone metabolites. My work was on Muzaffarnagari sheep, and it is the largest and the heaviest sheep and a mutton breed of India, and its home tract is UP. According to DHND reports of 1920, the sheep farming scenario in India is that there is a decrease in the wool production compared to the previous year. The main reason for this loss of production is the serious lack of organized farm and the lack of accurate pregnancy diagnosis in field condition. So, usually we have an invasive method, blood sampling, which needs the restraining and difficult and stressful handling. So we move toward the non-invasive method. But in non-invasive method, the milk progesterone assays and urine steroid. Milk progesterone assays is impossible in the milk utility sheep and drying of animals. And for urine, there is collection of urine for analysis requires animal handling and use of catheter, which is a laborious process. So, for an ideal for an ideal method of pregnancy diagnosis, which should be the simple, inexpensive and practical and safe, the fecal steroids have results in a valuable research source for the reproductive cyclicity, the time for ovulation, pregnancy and impending parturition, because it degrades slowly and abundant for the quantification. Then from the previous studies, there is a need to validate the fecal progesterone metabolites as a reliable pregnancy diagnosis in sheep breed. So we hypothesize the fecal progesterone metabolite 5-alpha pregnant, 3-alpha all 20 on could be a reliable non-invasive biomarker for pregnancy in sheep. So our objective was to study the serum progesterone and fecal progesterone metabolite in sheep during early pregnancy. Site of experiment were LPM, sheep and goat farm section of IVRI and division of physiology and climatology. The number of animal which we selected were the 16 Muzaffarnagari sheep, and after estrus synchronization protocol, the control group and the bred animals, the treatment group were divided, and then the fecal sampling and blood sampling were done on 4 days of interval, and day 0 were regarded as the day of estrus and day of mating for control group without mating, and treatment group which were loosely mated treatment group, and up to the 36th day of pregnancy we collected the sample. Then sample processing for fecal sample, the sample were collected directly from the rectum, and in a Ziploc pouch we dried off for 2 to 3 days for at 4 degrees centigrade in hot air oven, and grind off and using pestle and mortar, and then sieved off, and the powder is formed, and this is process for further extraction of progesterone metabolite. And by using the fecal extraction method described by Arjun, where 0.3 gram of powdered sample with 3 ml methanol as an organic solvent we used in vortex for 10 minutes, and then centrifuged and collected supernatant were dried and reconstituted in 1 ml assay buffer, and again vortex, and this preserved as a deep freezer until the assay. The immunoassay which were used, developed in NRL lab for 5-alpha pregnant, was utilized for the experiment, and the cross reactivity for the antibody 5-alpha pregnant was 100%, and 5-beta is 6.6, and for the 5 pregnant is 6.2, and 21 hydroxyprogesterone less than 0.1. Then come to the result. The data which were recorded for the cycling non-pregnant sheep from starting from the day 0 for the fecal and serum, as we can see that here there is a low it is the baseline, and recorded progesterone concentration for fecal progesterone metabolite is in day 0 to the successive day 4, day 8, there is an increase, and day 12 there is a maintain, and then again there is a significant decrease to day 16, and then day 20. That means there is a follicle end of the luteal phase at day 16, and again starting of the follicular phase in a cycling non-pregnant sheep. And then in
conclude it.
During in pregnant sheep, for both the serum and fecal progesterone metabolite, starting from the day 0 to day successive days 4, 8, 12, 16, there is an increase in the progesterone metabolite concentration in serum and fecal sample, and there is a maintenance of this concentration until the collection 36 day. That means there is a pregnancy is maintained, and the research results suggest that the fecal FPM 5-alpha pregnantriol assay provide valuable research resource for the identifying cycling and pregnant sheep, and greater concentration at day 24 and further to day 36 provides greater accuracy of diagnosis by the assay. Thus, fecal sample is a good tool for non-invasive pregnancy diagnosis, and for future prospective, it is a cost-effective and field application method, and upgradation of the small and marginal farmers through different diagnostic which could be easily performed to their doorstep.
Topic is open. Okay, you can ask.
As you have shown that fecal sample में ज़्यादा आसान है ना as a non-invasive type. तो मान लो I think सीरम में तो होना चाहिए था ना, उसका मेटाबोलाइट आता है ना इसमें, तो उनमें ब्लड में क्यों नहीं आया उसमें?
सर मैम, उसमें सीरम में प्रोजेस्टेरोन कंसंट्रेशन होगा और इसमें फीकल में प्रोजेस्टेरोन मेटाबोलाइट होगा. तो हम ये बोल रहे हैं कि अगर हम ब्लड के थ्रू जाएंगे तो वो नॉन इन्वेसिव है, तो हम
कंसंट्रेशन तो होना चाहिए ना ब्लड में भी.
तो मैम है कंसंट्रेशन है, ब्लड में भी है, बट फीकल में हम फीकल की तरफ जा रहे हैं ना, तो हमारा कंसंट्रेशन हमारा अगर इजीली फीकल में मिल रहा है तो
फीकल और ब्लड का जो है सिग्निफिकेंटली डिफर कर रहे हैं, नॉट सिग्निफिकेंट डिफरेंस.
फीकल और ब्लड वो कोरिलेटेड है मैम, हाईली कोरिलेटेड है. जैसा हमारे सीरम में मिल रहा है टेस्ट में, वैसे ही फीकल में मिल रहा है, बट लैग पीरियड की वजह से हमें फीकल में थोड़ी दिक्कत मिल रहा है. बट प्रेगनेंसी डायग्नोसिस के लिए हम फीकल के प्रोजेस्टेरोन मेटाबोलाइट को भी यूज़ कर सकते हैं.
Okay.
Thank you.
Next. 22.
RNE 22, Kajal Shankar Roy. RNE 22. 23, Pawanpreet Singh. Pawanpreet Singh and Feroz Ahmad Lone, sir. Please upload RNE 23.
Good afternoon, Chairman, Co-Chairman, Rapporteur and delegates. I am here to present part of the MBSc research work of my student. That is on homologous seminal plasma efficiently activates ephemeral tail sperm compared to traditional buffer and sperm tariff. So, a dead male animal or a human being can sire even after death. So, thing is that we have to retrieve the sperm from the abdominal tail, which is considered as a hidden treasure. So, those sperm can later be used in reproductive technologies, or they may be used to develop the very sperm banks. So in that essence, normally what happens during the normal ejaculation, the sperm, they emit from the chorda epididymis and they reach and join with the seminal fluid and they get activated. That is normally what happens. So once we get the same sperm we want to have in the under in vitro condition, so there we have to activate them. So if they have to get activated efficiently, the people have used many buffers medium like previously tris, sodium citrate powder, coconut and sperm talc have been used with varying success. So there's a knowledge gap that is seminal plasma has never been used because in ejaculated sperm it is with the sperm. So they are very that superior quality compared to the abdominal sperm. So what we have a hypothesis that is these RAM abdominal sperm may be activated efficiently in homologous seminal plasma compared to traditional buffer. So to pursue this hypothesis, we collected first the seminal plasma from this RAM. We selected these 5 healthy RAM, crossbred rams, known fertility at our model research station, sheep and goat. And then 80 ejaculates were collected by optional vagina. Then ejaculates were first screened for the quality, like mass motility score and initial motility. When they that they passed the quality check, those ejaculates were put to centrifugation twice. Initially they were centrifuged at 3000 G for 20 minutes, and later on they were again centrifuged. The supernatant was collected and again centrifuged for 30 minutes at 3600 G, and the seminal plasma was collected. It was ensured there is no sperm. We checked it under the microscope. If there happens any sperm was present there, we again went for the third centrifugation so that there is no sperm present in the fluid. So that was supplemented with antibiotics, and later on those samples were stored at 4 degrees centigrade till further utilization in the experiment. Then we collected these testicles from the slaughterhouse, and later on these testicles were the connective tissue were removed in the laboratory. Then those cauda tails were separated from the main testicles. Then first to check whether these testicles are fertile, from the fertile male, because that animal has been slaughtered. We don't know whether that was a fertile male or not. First we squeezed some amount of the with the syringe, a little drop, and they mixed it with the twist buffer. Once the sperm got activated, so we assumed that the testicles are fertile. Then these testicles, the cauda abdominis, were cut into 3 pieces. Then Then this quality was checked on the basis of these parameters. The set scale analysis was done. This is the motility. You see, we kept the 2 groups. One, the sample was kept as unextended and extended. In both the cases, the sperm motility was higher at 48 hours and 72 hours compared to we used the TARF as well as TRIS. So seminal plasma produced beautiful results. Again, the viability was significantly higher at 48 and 72 hours compared to TARF and TRIS in both unextended and extended cases. The viability, the functional viability was checked by host test, and again the parameters were this host reacted sperm were significantly higher at 48 hours and 70 hours compared to both traditional buffers like sperm, TARF and TRIS. Then intact acrosomes were also higher at 48 and 72 hours significantly. So this study clearly indicates that homologous seminal plasma is a better fluid, and it can activate the sperm efficiently compared to what we have been using the traditional buffers like TRIS and TARF. So this may be adopted for short and long-term preservation, and whenever the sperm are required to be used in assisted reproductive technologies, they have to be activated in seminal fluid as compared to the TRIS and TARF. Thank you.
Thank you, Pawan.
I'm Dr. Saraf Feroz. I'm presenting as my student.
Okay. Topic is open for discussion and questions. Not any question. The last subject of this session, 24. Again from
Army 24. Please upload Army 24.
respected chairman, co-chairman from the podium, and my delegates present over here. Though it is late, but thank you for being here, for your patience. And here now, good afternoon. And here I would like to present one of our studies that we have been taken in the buffalo, that is on the topic of immune modulatory effects of steroid hormones during gestation and early postpartum periods in Mura buffaloes. Why we have taken is that there is a reproduction failures in the buffaloes is quite high. So what we do is that we want to see the interrelation between the steroid hormones and the immune system and during the different reproductive phases. So therefore we have taken this study, and with this we have framed the objective that to study immunoendocrine interrelations during gestation and peripartum period in buffaloes in terms of mitogen-induced lymphocyte proliferation response, and at the same time we have also measured the nitric oxides. So therefore we want to see whether the lymphocytes of Mura buffalo is capable to secrete this, confirming for that we go for gene expression studies for iNOS gene. Then at the end we see the interrelation with the plasma progesterone, cortisols and the total nitrite levels and their regulations with the secretions of lymphocytes during in the in vitro cell culture we have seen in the culture supernatant. So these are the material methods that we have done, that the animal is being selected, 40 animals is selected from the NDRI cattle yard, and it has been divided into 5 different groups, 3 groups from different trimesters during the gestation period, 1 from peripartum and 1 from early postpartum period. Then in these animals we go for blood collections, and the blood is being in plasma. We measured for the hormones, especially progesterone and cortisol. Then even the total nitrite we measured from the blood. Then from the same blood we harvest the peripheral blood lymphocytes, and we go for in vitro culture in 1 million cells that we have been in each well for duplicate for each sample, and for 36 hours we cultured with and without mitogen, and the mitogen that we use is PHAP, that is Physiolus fulgaricus, and then we go for lymphocyte proliferation response after the culture of 36 hours, and then the cell supernatant has been estimated for the cytokines, pro-inflammatory and inflammatory estimation. At the same time, nitrite measure estimation were also being done, and at the end we also for gene expression for the lymphocyte cells of the buffalo, and we go for the statistical analysis with all the data that we have collected. So after that, the results from the blood, we could see that during the gestation period, the total nitric oxide in the form of the end products nitrite and nitrate. So these are the standard where we can able to measure it, and so therefore total nitrite that we measured during the gestation period was quite high as compared to the non-pregnant animal, and at the same time even prior to the parturition we can see that the level increased at -7, and it is then after which it starts to decline, and then early after the postpartum the level remains in a low level. Then in case of blood leukocytes we can see the changes increase during the gestation, at the same time dominated by lymphocytes and neutrophils. Then plasma progesterone and cortisols were also being measured, and here we can see the cortisol level. These two hormone high in their level is greatly affecting the interrelated with the changes in the in vitro cell culture and response, and at the same time their secretions into the cell supernatant, culture supernatant. So therefore progesterone level, which is being drastically declined on the day of parturition, whereas cortisol initially it increases with the gestation, but as the gestation period advances the level starts to decline, and the level decline low at the peripartum period, and after the postpartum it starts to increase again. Then lymphocyte proliferation response in this 36 hours culture, we can see the stimulated as well as stimulated with the mitogens. We can see their response and is quite high, significantly high, and this response, when we express it in proliferation index, we can also see that the expression was quite increased during the gestation, and even on the day 3 before parturition, then the level starts to decline. The response starts to decline. Then in case of nitrite secretion by the Mura buffalo cell culture in vitro, we could able to measure, and we can see that there is a significant high not only in blood plasma but even in the cell culture supernatant, and so they are significantly high during the trimesters, different trimesters, and even during the on the day of parturition were also significantly high. Then cytokines, pro-inflammatory cytokines and inflammatory cytokines, IL-2 and IL-6 we measured, and thereby we can see that they are also... Please conclusion. Okay, sir. Okay. So cytokines changes were also being changes during the gestation, and this we can see that the plasma cortisol, how they correlated with the cell immune functions in vitro. We can see that high plasma cortisol level related to decrease in the optical density of lymphocyte proliferation response during the gestation, both unstimulated and stimulated. Even in the gestation period and peripartum period, cell-mediated nitrate secretion in the cell culture supernatant were also being decreased during the gestation but increased during the peripartum period. Then we can also see that there is a plasma level, cortisol is decreases with the increases with decrease in IL-2 but increase in IL-6. We can also see that. Then plasma progesterone level, both optical densities in the lymphocyte proliferation response, stimulated and unstimulated, we can also see that there is an increase with plasma progesterone, there is a decrease in the lymphocyte proliferation response in optical density. Then we can see there is no response or interrelation with the plasma progesterone with the nitrite secretions in the culture supernatant, but we can see that in the cytokines there is a differences we can see both in gestation as well as peripartum period. So even the gene expression we could successfully express in the lymphocyte of buffalo with having 250 base pair, we could able to see their expression during the gestation, peripartum period, even in the postpartum period, and even in the reproductive disorder, but which I could not be put in this paper, in this presentation. So this is the summary that we have found from these studies, that there is a plasma total nitrite and progesterone level were quite high during gestation, and they try to reach at their maximum level prior to the parturition, but after then the parturition their level starts to decline, but there is a reverse pattern in case of plasma cortisol. Then the next is linear regression depict a strong relation of increased plasma progesterone level and as well as cortisol on the in vitro lymphocyte response during gestation and peripartum period. So from this study, what we could get is that there is definitely interrelations between the immune cells and the hormones, where the hormones and the plasma nitrite is also having a role in for the normal gestation period and the peripartum period. This we could able to get from this study in Mura buffalo.
Thank you. Last presentation, any questions and discussions? Good flow, good presentation. Thank you, ma'am.
Thank you, sir.
Now we are concluding this session. 50% presentations